All right, so now we're on to some new stuff, and we're going to solve some trigonometric equations. And we're not going to use graphing this time. We're going to solve it in a different way. This problem says, and it says warm up, find all values of theta when theta is between 0 and 2 pi, or from 0 to 2 pi, that satisfy the equation. All right, so first problem is sine of theta equals 1/2. And my answer is going to say theta equals whatever, right? So what you need to do in order to do this is use the unit circle, right? Figure out, since it's sine, where are all the y coordinates that equal 1/2? Find all those values on the unit circle, right? Turns out there's going to be two values. Those values, if you look at a unit circle, and I've got one handy, oops, just gave away all the answers there. Oh, upside down. All right, it's kind of hard to see. All the y values that are 1/2 are right here, so pi over 6. The other one is 5 pi over 6. And that was actually what I already wrote down, okay? Sloppy papers over here. All right, so I've got theta equals pi over 6 and theta equals 5 pi over 6. Super simple. This is not the same thing as saying sine inverse, okay? Because sine inverse, we would only have this answer, right? We talked about that last time. And we are not really graphing this, although you could. If you graphed y equals sine of x, and you graphed y equals 1/2, and you looked at where these two intersected, you'd get these two places if you were in radians, right? You'd actually get a whole bunch of intersections, but these would be the two between 0 and 2 pi. All right, so you could do that in Desmos if you wanted to. Really, the skill that I want is just look at the unit circle, right? Look at the y coordinate to equal 1/2. Now, that brings us to our next problem. If I have something like this, sine squared theta equals 1/4, you'll notice 1/4 is not on the unit circle that we see, right? So what you need to do is take the square root of both sides, right? Take the square root of both sides. When you do that, the square root of 1/4 is the square root of 1, which is 1. The square root of 4 is 2. You get 1/2, but you also get negative because it's plus or minus, right? So we've got sine of theta equals 1/2 and sine of theta equals negative 1/2. So now I need to look for when the y coordinate is 1/2 and when it's negative 1/2. We already know the solutions for when it's 1/2. It's just pi over 6 and 5 pi over 6. When is it negative 1/2? It's 7 pi over 6 and 11 pi over 6. And I just found that from looking at the unit circle, right? So that's the basic concept. You're trying to get sine or cosine by itself. Sometimes it's tangent. And you're trying to look at the unit circle. So you're using the unit circle to solve those. The two handouts that you should have, the two things that we're practicing right now, are this. Solving trig equations, number 1, right? PC 62A. And I want all of the solutions, and your handout should say something about all the solutions between 0 and 2 pi. That's what this number indicates. So for this one, there's going to be two values of theta between 0 and 2 pi that satisfy this equation. Here there'll be 2, here there'll be 2. And so what you're doing with these, like for number 3, you're going to add 1 to both sides, divide by 2 to get sine of theta equals 1/2. Here you're going to subtract square root of 2, add sine of theta to both sides. And you're going to work those out. That's section A. Then after working for about 5 minutes, go to section B. This is fractionals and multiples. How does this one work? Well, sine of 1/2 theta equals 1/2. What the heck does that mean? Well, we're talking about sine. Sine is talking about the y coordinate, and I know the y coordinate is 1/2. Okay. So sine of something, this mess, equals 1/2. Well, what would those angles be? Well, we just talked about it, and we said, okay, that's going to be sine of pi over 6 is 1/2, right? That's a true statement. We literally just did that problem. Sine of pi over 6 is 1/2. So that means this mess in here, 1/2 theta, should be equal to pi over 6, right? So now what's theta? Well, let's solve this. If I multiply both sides times 2, I get theta equals double this, right? And double that would be pi over 3. So that's one of the solutions. You can verify that with graphing. The other solution is going to be 5 pi over 6 equals 1/2. Sine of 5 pi over 6 equals 1/2. And so all I'm doing is I'm just looking, oh wait, I need to figure out what angle gives me 1/2. Take the mess that's inside, which is 1/2 theta, set it equal to that angle, and what's that going to be? So I've multiplied both times 2. I'm going to get 10 pi over 6, and I have to simplify that. So divide by 2 on the top, and I'll get 5 pi over 3 is equal to theta. All right? I don't know what this little mark is here. That should be, that's the answer for that type, all right? And I'm just going to keep moving on. You do that for all those. Then you're going to get to section C, and it says using factoring, all right? So 2 cosine squared theta plus cosine theta minus 1 equals 0. How the heck do I do that one? Well, I'm going to think of cosine as x. 2x squared plus x minus 1 equals 0. And I want to factor that. So since the leading coefficient isn't 1, it's not as easy, right? I'm going to use my box and diamond method. Okay, so the first term goes here. The last term goes here. I multiply those together to get the top of my diamond, which is negative 2x squared. The middle term goes here, and I'm looking for, that's a negative 2x squared. Two terms that multiply together to give me negative 2x squared and positive x. Well, that's going to be 2x and negative x. And that's what's going to go here and here, right? So then it's 2x and x, negative 1, 1. So my factors are 2x minus 1 and x plus 1 equals 0. And now that I have it factored, I'm going to plug back in my cosine. So my factors are going to be 2 times cosine theta minus 1 times cosine theta plus 1 equals 0. Now what do I do from here? Well, using the zero product property, if I set this piece equal to 0 and then this piece equal to 0 and then solve for cosine, I'll get this. I'll get cosine theta equals, if I set this equal to 0, I'd add 1 to both sides, divide by 2, I'll get cosine theta equals 1/2. Then I'd get cosine theta equals negative 1. And then I do the same thing as before. And in fact, that's what these instructions said to do. Factor the quadratic, isolate the basic trig function, then solve with a unit circle. So now I'm looking for the x-coordinate to be negative 1. And how many solutions did I have? 3. Okay? The last but not least, solve using identities. And we just did those. So solve using identities. I see a sine squared theta. I want to rewrite sine squared theta as, let's see, that's going to be 1 minus cosine squared theta. I don't really need parentheses on that. And then, let's see, that's going to equal 2 cosine theta plus 2. Now what am I going to do from here? Well, I'm going to move everything to the one side. So that's going to be cosine squared theta. If I add it to the other side, I'm going to have plus 2 cosine theta. 2, I'm going to subtract 1, so that's going to be plus 1. And then I need to factor it. What's the factored form going to be? It's going to be cosine theta plus 1 times cosine theta plus 1. All right? And then I need to set them both equal to each other, and I'm going to get cosine, set this equal to 0, set this equal to 0, so this is going to be cosine theta equals negative 1. And when I look for angles that satisfy this, I'm going to get pi. And like it said, I should have one solution.